Okay, let's look at this one where we're trying to figure out the Reynolds number of a situation where you have water that is at a certain temperature flowing through a tub. Actually, this should be tube at 2 meters per second. Gives you the size of the tub, really tube, and it gives you the kinematic viscosity. So we want to know what the Reynolds number is. Now, in order to get this, we're going to have to consult the FE reference materials. So I've provided to you the FE reference materials here just for the fluid section. You can see there's stuff on statics for different geometries. There's a section on fluid mechanics that goes over density and surface tension, pressure issues in a static fluid, and then forces on submerged surfaces, buoyancy issues, and then down to flow. So you see the field equation, or the Bernoulli equations, and then you see some things about airfoil, and then you get to Reynolds number. And this is what we need in order to calculate this question on the Reynolds number. Let's write down some important terms from this data set. We have the mean velocity of the water of 2 meters per second. So velocity is 2 meters per second. We have the kinematic viscosity, which is often given the symbol mu. No, is that mu? No, it's nu, excuse me, nu. 4.74 times 10 to the minus 7th meters squared per second. And what we want to know is the Reynolds number. Okay, let's go back to our reference materials. Okay, we can see that the Reynolds number is written as equal to the velocity times the diameter divided by nu, or the kinematic viscosity. So we have these terms, kinematic viscosity, and we just need to plug them in. So the Reynolds number is equal to the velocity, which is 2.0 meters per second, the diameter, which is 50 millimeters, and we know that there are 1,000 millimeters per meter, so we have the same units, divided by the kinematic viscosity, 4.74 times 10 to the minus 7th meters squared per second. This should give us a dimensionless number. I always like to check the units because, I don't know, it's fun. Meters times meters is meters squared, which crosses this guy out. Per second leaves this guy out, and the millimeters go away here. So we end up with, 2 times 50 is 100, divided by 1,000 is 1/10. 2 times 50 is 100, yeah. 1/10 divided by roughly 5 times 10 to the minus 7. So I'm just really going to ballpark this. We have 1 over 5 times 10 to the minus 8th. I've turned this the 1/10 here on the top to 10 to the minus 8th here. You can see this is a big number. This becomes, this is 0.2 times 10 to the 8th, or roughly 2 times 10 to the 7th. That is much, much bigger than the boundary condition that when the Reynolds number is greater than 10,000, it is fully turbulent flow. So this tells us that the flow is fully turbulent.